Welcome to TechieWise. In today's video, we will be having a discussion on Simplified DES, which is designed only for educational purpose to just have an idea of how the standard data encryption standard works. All right. So this is the basic. This is the overall architecture diagram of Simplified DES. So yeah, this Simplified DES handles 8-bit plain text and convert it into a 8-bit ciphertext, right? And the input size is 10-bit. So according to the Simplified DES, the user will be giving an 8-bit plain text and 10-bit key to proceed with the processing. This is the sequence of steps involved in processing the 8-bit plain text. So this similar version of DES. So it has a initial permutation. So the next step is going to be a F function, and there is a swap and again a F function. The meaning is it has 2 rounds. The regular DES has 16 rounds. Here in this case, it has 2 rounds. What about the standard DES? It deals with 64-bit plain text block and 64-bit key. That 64-bit is reduced to 56 bits and then proceed with the key generation process. So strength of the algorithm is dependent on 2 to the power of 56. Right. So here in this case, it involves 2 rounds and then again an inverse initial permutation. It gives an exact feel of the standard DES, just a feel of the standard DES. And this is going to be the decryption part. So inverse, the ciphertext is will come across the initial permutation and then the F function, which uses the K2 swap, and then the F function which uses the K1, KK1, and then the inverse initial permutation, and the output will be the equivalent ciphertext. So here we will have the ciphertext. Right. So with regard to the key generation, so similar to the standard DES, each round will get a unique key which is generated from the key given by the user. So here 2 rounds, 2 keys are required. So here this 10-bit key will come across a permutation choice, so which we call it as P10. The details on it we will discuss now. Then comes a leftist shift and again a permutation. So it is similar to that of permutation choice 1 and permutation choice 2 in the standard DES. And this output, once the permutation choice is done, that output is the key for the first round, and then the output of the left circular shift, right before permutation P8, that output will be used for the generation of keys for the second round. So again a left circular shift, and then it comes across a permutation choice P8. That output will be the key K2. So similar to that of DES. Hope you can recollect. In the standard DES for key generation process, round 1, 2, 9 and 16 will come across a 1-bit left circular shift, and the rest of the rounds will come across a 2-bit left circular shift. So similarly here also in each and every round will come across different set of bits that we can have a look into now. So before proceeding with the encryption process, we need 2 keys to be generated. So we are going to start with the key generation. So actually this simplified DES, we are using it to get a feel of how the computational task done in the case of DES to generate the ciphertext. Right. So here this is P10. So key generation process involves 2 different permutation choice, P10 and P8. So this is going to be the one with P10. So here we are going to deal with the 10-bit data. So let us take a sample key. So using this key only, we are going to encrypt the plain text. So here the key is 101000001. So this key is going to come across this permutation. So this is position 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So what will be the output of P10? So the output of P10 will be, first bit is the bit in the third position. So 1. What about the second bit? Bit in the fifth position. So it is going to be 1 0 0 0 0 0 1 1 0 0. So this is the output of the permutation choice P10. So it's in the similar way. So when you recalculate the standard DES, when it comes across the permutation choice 1, 64-bit is reduced to 56 bits. Some bits are removed and then there will be a permutation. So here in this case, instead of reduction, the just permutation is done, right? And next comes the left shift, right? Left shift. So here in this case, first round will come across. In the case of first round, we will come across a 1-bit left circular shift. It will come across a 1-bit left circular shift. So here, hope you can recollect. In standard DES, 56 bits is divided into 28 and 28 bits, and each 28 bit will come across the left circular shift. Same way, so here this is going to be divided into 5 bits and 5 bits, and then it will come across a left circular shift. So first block coming across a left circular shift by 1 bit. So what will be the output? 0 0 0 0 1, and the second block, it is 1 1 0 0 0, right? So this is the output of left shift by 1 bit. Now again, what is the next step? It will come across the permutation table, permutation choice P8. So here you can see the 10 bits is reduced to, again a permutation is there. In addition to that, 2 bits are truncated. Hope you can recollect in the standard DES, 56 bits will come across the permutation choice 2, and then it will reduce to 48 bits. So here in this case, in order to give a feel, the 10 bits is reduced to 8 bits with addition to the permutation. So this is how the permutation will happen. So here we can just make a note of the number, positional values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what will be the output of permutation table P8? So the bit position 6, what is the bit in position 6? 1, and next in bit in position 3 is 0. So the output is 1 0 1 0 0 1 0 0. So this is key K1. So here you can see, so this is key K1, output of permutation table P8 is key K1. Now we can proceed with generating the next key. So what is the next key? So the next key is going to be before shifting, that is without reduction, right? So that is given as input to the shift function. So here in this case, for second round, it is left shift by 2 bits. Okay, left shift by 2 bits. So which should be shifted? So this should be given as input. Before permutation, this should be given as input. So here, second round, left circular shift by 2 bits. So what will be the output? So let me just make a note. So the input given is, that is input in the sense, input of left circular shift is 0 0 0 0 1 1 1 0 0 0. So this is the input given. So what will be the output of left shift by 2 bits? Yeah, so 2 bit. So 0 0 1 0 0. So this 5 bits separately and this 5 bits separately. And here it is 0 0 0 1 1. So now this will come across the permutation table P8. So what is the output of P8 now? So this is a bit position. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the permutation here? So 6th bit, which is the 6th bit? 0, and 3rd bit is 1, 0, 0, 0, 0, 1, 1. This is key K2. So this is how key generation happens. Now, I hope you can understand how the key generation process takes place in the standard DS. Of course, this is not the exact replica. Instead, it gives us a feel how the process works. There it deals with the 28, that is 28 plus 28 bit value. Now, with this information, we can proceed with the encryption process. So here in the encryption process, 8-bit plain text is taken and it comes across the initial permutation. So here, this is the initial permutation. So this is the initial permutation. Let us take the plain text. So this is the plain text which is going to get encrypted. So 1 0 0 1 0 1 1 1. So this is our plain text. So let me just make note of the positions here. 5, 6, 7, 8. So what will be the output of initial permutation? Output of initial permutation is second bit. What is the bit in second position? 0. 6 is 1, 0, 1, 1, 1, 0, 1. So this is the output of the initial permutation, right? Next comes the F function. So what is the F function here? So F function which will take this left half and right half, right? Hope you can recollect. DES handles the data into two different halves, left half and the right half. So here left half and right half. So it is going to be processed in such a way that left half is XORed with F of, this is F function, F of right half comma sub key, okay, sub key, and then comes the right half part, right? So this is going to be how the process works. Now we have the initial permutation. Now we are going to proceed with the process. So your plain text is divided into two halves, left half and the right half. Hope you can recollect. So here we are going to process the right half. The right half is going to come across the F function. So which is going to be XORed with the subkey. What is the size of the subkey generated? Size of the subkey generated is 8 bits. But the right half is of 4 bits. So how to deal with the process? This 4 bits should be expanded to 8 bits. In the standard DES, what we will do, the 32-bit will be expanded to 48 bits. So how it is expanded? We will take 4 bits and each bit will be appended. So all the 32 bits will be placed as 4-bit blocks and each block will be appended with the bit of the previous block and the first bit of the previous block and the last bit of the previous block and the first bit of the next block. Similarly, here we are dealing with the 4-bit value. So how it is going to handle things? So this is how it is going to handle the things. 1, 2, 3, 4 are the 4 bits. Each bit is going to be, here in this case, 4 bits should be expanded as 8. So each 2-bit block should be expanded as 4-bit block. So each block is going to be appended with the last bit of the previous block and first bit of the next block. So this is going to be 4, 3 and this is 2, 1. So similar way, similar to that of the DS. Only thing is we are handling with a smaller sized value. That's it. Right. Now we can proceed with the process here. So here 1, 1, 0, 1 should be expanded. So 1, 1, 0, 1. So how it is going to be expanded? It is going to be appended with the last bit of the previous block. Already we discussed it will be considered in a circular fashion and the next bit, first bit of the next block. And here in this case, it is going to be appended with the last bit of the previous block and the first bit of the next block, right? So after expansion, we will have a 8-bit value, right? So now we can perform the XOR operation. So this is the expanded right half and we are going to use the key. We are in round 1. So which key should be used? Key K1 should be used. This key should be used. So we are going to XOR it. So 1 0 1 0 0 1 0 0. So this is key K1, right? Key K1. So this is K1. So now what is the output? Just XOR operation. So it is 0, 1, 0, 0, 1, 1, 1, 1. Right? 1, 1, 0, 1, 0, 1. Right? So this needs to be, hope you can recollect in the standard DES, 32-bit is expanded to 48-bit and then it is XORed with the subkey of that particular round, and that output will be of 48 bits. That 48 bits should be reduced to 32 bits, right? Again 32 bits. Only then we will have the equivalent sized ciphertext block. Similarly, here we have expanded to 8 bits. This 8 bits should be reduced to 4 bits. So here in this case, we will have so here we have we have 8 bits, right? So here 8 bits, each we have 2 S boxes. In the standard DS, we have 8 S boxes. Each S box will take a 6-bit value and it will generate a 4-bit equivalent output, right? So it will take a 6-bit input and produces a 4-bit output. So here in this case, we have 2 S boxes and each S box will take a 4-bit input and produces a 2-bit output. Let me, okay. So this value will be given as input to S box 1 and this will be given as input to S box 2. With this, I have to generate a 2-bit output, right? So I have to generate a 2-bit output. So here, this S box for representing. So here in this case, we will have 4 rows and 4 columns. Each S box is going to have 4 rows and 4 columns, and each entry in the S box will have a 2-bit value, right? So because the output of S box is going to have to be a 2-bit value, so the entries in the S box will be a 2-bit equivalent value. So for representing 4 rows and 4 columns, how many bits are required? 2 bits to represent the row and 2 bits to represent the column. So just we can have a look of the S box now. So this is S box 1. So these are the entries in S box 1. So 1, 0, 3, 2. Here you can see all the values ranges from 1 to 3. In the previous case, the output of S box is going to be a 4-bit value. So all the entries will range from 0 to 15 in the case of standard S box. So standard DES. So here in this case, we are using a miniaturized version, almost a miniaturized version. So this is S box 1 and S box 2 is 0, 1, 2, 3. All these are predefined values. So please make a note. S box, initial permutation, inverse initial permutation, P10, P8. The same thing with regard to the standard DVS, permutation, table. All those things are predefined one. Okay, so this is S box 1 and this is S box 2. This is going to be given as input to the S box. In the standard DS, 6 bits are given as input to the S box. First and the last bit are used to represent the row and intermediate bits are used to represent the column. So similar way, here in this case, S box 1 will take a 4-bit value and S2 will take this 4-bit value. First and the last bit are used to represent these 2 bits are used to represent the row and intermediate bits are used to represent the column, right? Intermediate bits are used to represent the column. So what will be the output here? So this is, let us just number it, 0, 0, 0, 1, 1, 0, 1, 1 and this is 0, 0, 0, 1, 1, 0. 1, 1. So what will be the output of S box 1? So this is 0, 0, 0, 0 and the column is 1, 0. So what is the value? 3 is the value of this particular S box. So 3 I can represent it in 2 bits, right? So what is 3? It is 1, 1. So the equivalent is 1, 1. 0, 1, 0, 0 is reduced to 1, 1. And what about this one? So these 2 bits are used to represent the row and these 2 bits are used to represent the column. So this is 0, 0, 0, 1, 1, 0, 1, 1. So this row and this column. So what is the value? 3 again. So this is the output of S2 is 1, 1. Right? So now, okay. So what is the output of S box? So output of S box is 1, 1, 1, 1. Now this is P. The output of S box will come across the permutation table P4. So this is P4, 2, 4, 3, 1. So after permutation, so all these are bit 1. So what will be the output? 1, 1, 1, 1. So according to the F function, this processed right half will be XORed with the left half. So XORed with left half. So here left half is 0, 1, 0, 1. What is the left half here? 0, 1, 0, 1 is going to be XORed with 1, 1, 1, 1. So what is the equivalent? 1, 0, 1, 0. Again, there is going to be a swap. So here you can see there is a swap function. So after round 1, it is coming across a swap function. Yes. So what is the output actually? So here, once it is done, so it is 1, 0, 1, 0 and the right half is 1, 1, 0, 1. Now there is going to be a 4-bit swap. Now the output is 1, 1, 0, 1, 1, 0, 1, 0. So here this is the F function we discussed now. Left half XORed with the F output of F function, comma, right. So that is what we have written here. And again there is a swap. So now this is going to be given to the second round. So this is given as input to the second round. Again the same sequence of process. So here this is L2 and that is this is the left half and this is the right half. Again proceeding with the expansion of the right half. What is the expansion here? 1, 0. 1, 0, 1, 0 needs to be expanded. So each bit is going to be, that is 1, 0, 1, 0 is going to be expanded. So this is 0, 1, 0, 1. So what will be the output after expansion? 0, 1, 0, 1, 0, 1, 0, 1. Now this is going to be XORed with the round key. So that is key K2. So what is key K2? So this is key K2. So now XOR it. 0, 1, 0, 0, 0, 0, 1, 1. So what is the output? 0, 0, 0, 1, 0, 1, 1, 0. Now this should be reduced to 4 bits. So this will be given as input to S box 1 and this will be given as input to S box 2. So these 2 bits are used to represent the row 0, 0, 0, 1, right? These 2 bits are used to represent the row and intermediate bits are used to represent the column. So what is 0, 1 and 0, 0? 0, 1, 0, 0. What is the value here? 3, right? So it is 3 and 0, 0, 0, 1, 1, 0. So 0, 1, 1, 0. So these 2 bits to represent the row and these 2 bits to represent the column. So 0, 0, 1, 1. 0, 0, 1, 1. Again we have the value 3. So what is the output? 1, 1, 1, 1. So again it will come across the permutation table P4. So what will be the output? As all bits are 1, it will remain the same. Now this should be XORed with the left half. That is left half of round 2 input. Left half of round 2 input. So that is which is the left half of round 2 input. So this is the round 2 input. So 1, 1, 0, 1, this left half, right? 1, 1, 0, 1 XORed with 1, 1, 1, 1. So the output is 0, 0, 1, 0. This is the, so now it is going to be 0, 0, 1 0 1 0 1 0, right? So here you can see. So this is the unprocessed right half and this is the XOR output, right? So as per the algorithm, there is no swap after round 2. There is no swap after round 2. Then we have the inverse initial permutation. This bits will come across a inverse initial permutation. So inverse initial permutation, this is the permutation here. 4, 1, 3, 5, 7, 2, 8 and 6. So this is the permutation. So what will be the output of inverse initial permutation? This is 1, 2, 3, 4, 5, 6, 7, 8. So here the output will be fourth bit. So what is the fourth bit? 0. What is the first bit? 0, 1, 1, 1, 0, 0, 0. So this is the 8-bit ciphertext. So here you can see even for 2 rounds, dealing with 8-bit entries, it is not manually possible. So in hope you can have you can directly map this with the standard DS and have the feel how many times the iterations will go on. The sequence of process will go on for 16 rounds, right? 16 rounds. So let me repeat, this is just for educational purpose to just have an idea on how the standard DES works. Ciphertext of SDES, simplified DES. In the next video, we can have a look into the advanced encryption standard. Thank you.